Hello, welcome to our webinar, What's New in SigmaXL version 10. My name is John Noguera. I am the Chief Technology Officer at SigmaXL. Welcome, and we're happy to have you here to discover what is new in SigmaXL version 10. This is part 1 of 3, Tool Selection Guides, Data Manipulation, and Graphical Tools. By the way, just for your information, this is our website, and this is my LinkedIn address, and you are welcome to connect with me on LinkedIn. In terms of format, the presentation is approximately 45 minutes, and then we'll open it up to questions and answers. Please type your questions in. We have to mute participants during the webinar to keep background noise low. And in terms of questions, we would like if you could type those in, and then I will pick those up at the end of the session. The PowerPoint additional data will be available for download on our website. And as well, this webinar is being recorded, including the questions that are asked and answered, and that they will be available. It takes usually a couple of weeks before the webinar is available. So without further ado, we'll begin. So our agenda, we're going to cover just the new items in version 10, which include the Graphical Tools Selection Guide, the Hypothesis Test Selection Guide, the Revised Control Chart Selection Guide, new data manipulation tools, which include raw data to frequency, which is the tally function, and frequency to raw data. We'll look at the new graphical tools, Heatmap, interval plots and multiple X interval plots, empirical, normal, cumulative distribution function plots, and the XYZ contour surface plot, and then Q&A. We'll begin with the graphical tool selection guide. And I think what I'll do is I have everything on PowerPoint, but I will start with the graphical tools. Now, the graphical tools selection guide was added as a way to guide you through all of the graphical tools that are in SigmaXL. And that is available here under Graphical Tools Selection Guide. It's also available under Help, what graphical tools should I use? Okay, so that's basically 2 ways to get to it. And when you open it up, you are prompted for data type, continuous or attribute, discrete. If your data are continuous, then what is the purpose of the graph? Are you interested in looking at a distribution? Are you interested in looking at center spread and outliers, confidence intervals? Are the data time varying? Are you interested in XY relationships, XYZ relationship, sources of variation, normality, CDF, or analysis of means? So depending on what you are really interested in looking at will determine then what tools pop up as available. So let's say, for example, center spread and outliers. Well, the tool for that is the box plot or the multiple X box plot. If you're interested in confidence intervals, that's our new interval plots and multiple X interval plots. So I'll be showing that in a moment. But I'll go back to distribution here because that's pretty straightforward. So the first one that comes up is the basic histogram. So when you're using the graphical tool selection guide, what you want is you want to already be in the data of interest. All right, you're ready to analyze the data. It's already pre-selected is the easiest way to go. And then you pop up with the tool selection guide. Your data's been pre-selected, so you're good to go here. And we're going to do a basic histogram of overall satisfaction. Okay, so there's our overall satisfaction basic histogram. So again, the idea is to give you in one place all of the graphical tools based on the purpose of the graph that you're interested in. This is also a new one, the CDF plots. The analysis of means has been around for a while, but if you go to analysis of means, you see the various options that are appropriate for continuous data. Now, when you switch to attribute data, now the purpose of the graph does change. For example, I want to prioritize. Well, the basic Pareto chart comes up. So let's say I want to look at a Pareto chart of major complaint. So I'll do major complaint and produce a Pareto chart. And here I see return calls is my number one major complaint. All right, so that's the Graphical Tools selection guide. It also, if you go to compare, you get the new heat map, you get the pivot charts. If you go to analysis means, then you get the anom charts that are designed for attribute discrete data, which is binomial proportions and Poisson rates. Okay, so that's it. It's basically everything's there, makes it nice and easy. If you know the specific tool that you want to use, then just use the menu to get to it. But if you're not really sure, especially in a training situation, you're just getting familiar with the tools, then this is a great summary to kind of guide you to the right tool. And of course, you can still experiment and try different things out. So that's the graphical tools. Then the next one that's new is the hypothesis test selection guide. All right. Just a comment, you can either go with raw sample data or summarized sample data. If you have summarized sample data, you'll be using a template. If you have raw sample data, you'll be going through the menu. Again, just like we did with the graphical tools, you want to pre-select the data and then use the hypothesis test selection guide. Note that regression, correlation, and general linear model are not included in this guide. All right, that's something we'll put in a future version, but for now, it's strictly hypothesis testing. So I will switch over now. And so in terms of access statistical tools, it's right up at the top, so nice and easy to get to, or you can go help, what statistical tool should I use? All right, so we go statistical tools, hypothesis test selection guide. So same idea. The first prompt is, are the data continuous or are they attribute discrete? And then depending on what you select, will pop up with the appropriate tools. The next item is, what is the test type? Is it a one sample, two sample, one way, so basically more than two? You're comparing, say 3 samples or more. And then two-way, where you have 2 group category X's. So if I have, say, continuous one sample, I want to compare it to a hypothesized mean, then you are presented with the option either raw sample data, in which case you'll use the one sample t-test, or summarized sample data. And when you do that, you have a template and there are more options available, including the equivalence test. So again, it has the hooks into every hypothesis test in SigmaXL, but in a nice, easy to reference format. So that includes also median, non-parametric, so you can look at whether, again, one sample, non-parametric, you can use the Wilcoxon exact, one sample sign, and we have some guidelines here, just runs test exact. The exact tests, the non-parametrics, are used for small sample sizes when the assumptions are not met, so they're a better choice, but they do take longer to compute. So that's, let me just demo 2 sample mean. Let's say I want to do 2 sample means and I want to go to 2 sample comparison tests. So I have continuous data, 2 sample, I want to compare means, I have raw sample data, and I want to be able to test normality, variances, means, and medians, kind of everything in one shot. And there we go. So 2 sample comparison test, I want to do overall satisfaction by customer type. And I have to specify what groups. In this case, I'll use 1 and 2. And here we have our 2 sample comparison. This tests the normality of each group. Depending on the normality, highlights the appropriate test for equal variance. In this case, Levine's test, because group 2 is not normal. And then depending on the test for equal variances, the appropriate t-test is highlighted. In this case, assume unequal variance. So the means are in fact different because the p-value is low. Okay, so that's our two-sample comparison. But again, the key here is just using the guide to assist you with the selection of the tool. And there are a lot of tools, and it's growing. We will keep this up to date when we add new tools, and you will see that as you saw in the graphical heat maps, for example, are included in the guide. And as we go forward and add new tools, they will be added to the selection guides as well. All right, so basically that's it for hypothesis test. Also new under control charts, we have the control chart selection guide. I'm not going to go through that, just to point out that the new charts that have been added recently, rare events, the templates, the time-weighted EWMAQ sum and the trend have been included, have been added. The control chart selection guide has been there for a long time, but we updated it with the new charts, or with the recent charts. Okay, so those are the selection guides. And what I want to do now is talk about convert raw data to frequency, basically a tally function. So it's just converting raw categorical data to frequency. It's the same function as count in Excel pivot table. It's just easier to use. And a caution, if you accidentally select a continuous variable, you will get a warning message if there are more than 50 unique levels. And typically it's because you chose a continuous variable rather than a categorical variable. Just kind of a note here. And we'll do, with the customer data, we'll do the tally. So I go data manipulation, frequency conversion, convert raw data to frequency. And I'm going to do customer type as my first categorical variable. I'm going to do size of customer. I'm going to do major complaint and product type. And I'm going to show both frequency and percent. So this shows me here a summary for customer type, what the frequency is and what the percentage is and the total. And so size of customer, major complaint, and product type. So it's just a nice, quick and easy way to do a tally. Now, sometimes you also want to take it in reverse. Let's say what you have is summary data. You have frequency data, and you'd like to be able to do maybe some graphical analysis that requires raw data. So what you can do is let's just highlight this. And if I highlight the customer type and the frequency, what that will do is that will convert the data. I can go back the other direction and convert it to raw data. So that's going frequency conversion, convert frequency to raw. And frequency goes up here. Customer type is my categorical variable. And all it does is it just prints out, or basically gives you a column with the customer type value repeated. So that's just a convenience item. And that's our data manipulation. Now, heat map. The heat map is a graphical tool that is used to display counts or summary statistics in pivot table format with the results gradient color coded. The minimum is dark blue and the maximum is dark red. This allows you to easily slice and dice your data, quickly look at different X factors and their contribution to the total, or summary statistics like the mean, aided by the color coding. Up to 3 row categories and 3 column categories are permitted. If you do not specify a numeric response, then SigmaXL will use counts as the statistic to display. And if a numeric response is specified, you have lots of options. And this gives the heat map a real edge over pivot tables, whether it's R pivot tables or Excel pivot tables. You have a lot more choices. For example, the median is not available in the pivot table. Percent less than a specified value. All right. Interquartile range. So you just have a lot more choices. You'll see it's also very easy to use. So with that, I will switch over and go back to the customer data. And we'll go to Graphical Tools. And we'll go to the heat map. And we'll do, let's see, for row categories, we're going to do major complaint. For column categories, we'll do customer type. We will not put in an optional numeric response, which means we're going to get a count. And I can zoom that in. And there we go. So we have our count, major complaint by customer type. And return calls is highest, the maximum for customer type 2, and not available is the lowest also for customer type 2. So it just gives you a nice, easy way of comparing, aided by the color coding. Just as an aside, if you don't like the color scheme, conditional formatting, so you can actually, like if you wanted to change the color schemes, you can do that. But, I think our color schemes are pretty good, but just if you wanted to modify it, you can do that under conditional formatting. So let's look at a few other examples. I'll just use recall. And now what I'll do is I'll do customer type as the row category. Actually, let me get rid of major complaint first. Get rid of customer type. So I want customer type as the row. I want size of customer as the column. And I want overall satisfaction as the optional numeric response. And the default is the mean, but as I mentioned, there are lots of options, a lot of statistics you can select, and we'll look at a few of these. So right now, we'll just look at the mean of overall satisfaction by customer type by size. And again, I'll zoom in to make it easier to see. And here we have maximum mean SAT score, large customer type 2, and minimum in the dark blue for large customer type 1. All right, so this is, again, just giving you a nice bird's eye view of your data. Obviously, just because numbers are different and color coding doesn't mean statistical significance. You need to complement your analysis with hypothesis testing and so forth, and perhaps other graphical tools. But it's just a nice alternative way of quickly looking at your data in the same way that you would with a pivot table, but just giving you ease of use and a little more flexibility. So the next example we'll look at, again, I'll do recall. This one, I'm only going to look at customer type, and I'm going to change the statistic from the mean to the standard deviation. So, all right, so this one, just make that a little bigger. So here, now I'm looking at standard dev, and customer type 2 has the minimum standard deviation. So customer type 2 with the minimum standard deviation is good because that means a more consistent level of satisfaction. So the mean, you want the mean to be higher, but you want the standard deviation to be lower. All right, so that's standard dev of overall satisfaction. Let's say we want to look at the median. So now I'll change it from standard dev and I will select the median. So again, we can see that for customer type 2, the median SAT score is the highest, and customer type 3 is the lowest. Another one that's nice that we can do is say percent less than a specified value. So let's say, okay, so what we're going to do is we're going to say SAT score of 3.5, less than 3.5 is considered a defect. So if I put in a specified value of 3.5 and I run this, now what I'm looking at are the percentage of dissatisfied customers. So in this case, smaller is better. So customer type 2 has 11.9, customer type 1 and 3 are very similar in terms of percentage less than 3.5. That's something you can't get in a regular pivot table. So the heat map gives you the additional flexibility. Now, another thing that is quite nice on the heat map, and I'll just pull up the slide, you can use, we're going to use year as a column category. And what we have are mobile cellular subscriptions per 100 people by region and year, global region. This is from the World Bank data. It's freely accessible. With that URL, you can get the data yourself. I have filtered the data so that I'm only looking at regions, and I'm looking from 1990 to 2021. Now, let me go back and pull that data up. This is the data, and it has the region, the year, and the mobile cellular subscriptions per 100 people. Now, this data set will be available with the PowerPoint because it's not part of the sample data. This is something we added for this webinar. So we have, again, Graphical Tools, Heatmap, and I'll put region in the row category. I'll put year as the column category, and the cellular subscriptions per 100 people, and we'll look at the mean and run that. Takes a few seconds to produce it. And here we can see that in 1990, the dark blue shows that it's a very low usage in terms of mobile phones. And as I scroll across the time, you can start to see, well, first Europe and Central Asia and North America, but then as we continue on, the rest of the world catches up. All right, and granted, still in 2021, you know, there's a divergence, but it's you know, it's pretty common, regardless of where you are in the world, to have a mobile phone. And what's interesting is if you look in some of these numbers, people have more than one subscription. So that's basically your people who have business phone and a personal phone. You know, that would be probably the best or the most likely explanation as to why there are more than 100 mobile subscriptions per 100 people. Okay, so again, it's just a nice visual using time or using year as your column, and you can scroll across and get that nice visual. So that's kind of a nifty application of the heat map. All right, so that's the heat map. And next, I want to look at interval plots. So interval plots, by the way, we already have interval plots in the ANOVA, in the one-way ANOVA, and similar in multivary, you can specify confidence intervals. But this is nice because it's standalone, and the interval plots standalone, if you turn off the confidence interval, become main effects plots. So that's a nice way of analyzing your data, quick and easy way of looking at your data, and you have multiple X interval plots as well. So confidence intervals are computed as unpooled. So if I have customer type 1, customer type 2, customer type 3, those are treated as separate groups, okay? If you want pooled, you have to use one-way ANOVA or general linear model. We'll talk about general linear model in the next webinar a month from now. So as I said, you can uncheck display confidence intervals to produce a main effects plot. And so with that, let's just do overall stat by customer type. So we'll do graphical tools, interval plots, overall stat by customer type. And I'll turn on the confidence intervals. The default confidence level is 95, but that can change. The title says unpooled so that you know how it's calculated. And you can see here, there's customer type 2. There's no overlap between 2 versus 1 or 2 versus 3. So you can conclude that they are significantly different. And that, of course, is also what you get when you do a hypothesis test. Let me go back to the PowerPoint and just talk about, so this is what I mentioned. We can see that customer type 2 has a significantly higher level of mean. There's no overlap. And between 1 and 3, there's lots of overlap. And then use hypothesis testing to more precisely compare. But this gives you a nice visual guide. Multiple X interval plots, similar to multiple X box plots. So basically one Y variable and multiple group category X's. And again, if you turn off the confidence intervals, you essentially have main effects plots. Be careful when doing this. Do not select a continuous variable for the group category variable, as each unique value will be considered a category variable level, and you will be given a warning if there are more than 50 levels detected. All right, so now multiple X interval plots. So we'll go graphical tools, multiple X interval plots, and we'll do overall satisfaction, and we'll do customer type, size of customer, major complaint, and product type. We will display the confidence intervals for now. So this allows you quickly, you can scroll across and compare basically the effects. Because you have the confidence intervals, you can also pick up the statistical significance. So here you can see 2 is significantly different than 1 and 3. But you can see for size of customer, no significant difference. Here, again, lots of overlap on the confidence intervals. So customer type is really the only factor that appears to be significant. But again, this would be tested with hypothesis testing. The only factor with non-overlapping confidence intervals is customer type. You can use either one-way ANOVA or general linear model to do hypothesis testing. Now, I'm going to rerun this, but this time I'm going to turn off the confidence intervals. And this now essentially becomes a main effects plot, so you can just quickly, it scales everything the same. The items with the steeper slope have greater effect. The confidence intervals, of course, use up some real estate. So by removing them, you're able to see things a little more clearly. But be careful, again, just because you have difference in slope, that doesn't necessarily mean they are statistically significant. But this is a nice, quick and easy way to compare X factors. All right, so that's the multiple X. And the next thing we want to look at is the empirical normal CDF. So the empirical normal CDF, the CDF is the cumulative distribution function, shows the data values sorted from lowest to highest on the x-axis with the respective percentiles on the y-axis. And they may be compared against the same for a fitted normal distribution. It's similar to the normal probability plot, but instead of a straight line, it gives you an S-shaped curve. The empirical data is plotted as a blue stepped line, whereas the fitted normal distribution is a smooth red line. Large deviations between the two indicate that the data are not normally distributed. So, what we're going to do first is we're going to generate some random data. SigmaXL, data manipulation, random data, normal. I'll just use the defaults, create 100 rows of data, normal data, and select it. And then I'll go Graphical Tools and run the empirical normal CDF plot. And you can see the empirical follows the normal fairly well. You're always going to get slight deviations. And by the way, of course, that's why you have to do, you can't just look at this thing graphically and conclude normal or not normal, but you can get a rough idea. And I'll give you an example where we do have clear non-normality. But you would always complement this with a normality test. Okay, so that's the normal data. And now what we're going to do is I'm going to go back to my customer data, and I know that my overall satisfaction is not normal because it has an upper limit of 5. In fact, let me just do a quick histogram of overall satisfaction. And you can see it's skewed left. If we do a normal probability plot, Graphical Tools, normal probability plot, and I look at overall satisfaction, this has the interval bounds that make it clear that the data is not normally distributed. So between the histogram and the normal prob plot. But so now what we want to do is we want to look at the same, but we want to use the CDF plot. So I'll go Graphical Tools, Empirical Normal CDF, and overall SAT. And here you can see right up at the top where it levels out. All right, that's basically at 5, you've hit 100%. So it's definitely not what you expect for from a normal distribution. Okay, it's just another camera angle, another way of looking at the data. It's also in the 2-sample Kolmogorov-Smirnov. You can actually compare the CDF of 2 distributions. And on the third webinar, we'll cover, and we'll use the CDF plot just to kind of illustrate how it looks at the difference in height between the 2 CDFs. Okay, so that's another graphical tool that has been added. Just a helpful view. It's equivalent to the normal probability plot, where the normal probability plot is scaled to form a straight line. This is showing you the percentages, so you can just, it's more true to what's going on with the actual data. All right, so that's normal CDF. XYZ contour surface plot. All right, this is a very nice tool. It's used to plot a continuous response Z versus 2 continuous predictors Y and X in order to understand the possible relationship without a regression model. All right, that's the key. Is it does interpolation and extrapolation to create a contour and a surface plot. It does that by creating a mesh or grid of regularly spaced X and Y values. The default mesh size is 20 by 20. So there are 400 points, but this may be modified. Available interpolation extrapolation methods include automatic with cross-validation, and this is, by the way, what we recommend. let the software do the hard stuff. There's inverse distance weighting with power. I'm not going to get into the details. By the way, in the appendix of the SigmaXL workbook, you have all the formulas and reference papers and so forth, getting into the mathematical details. Inverse distance weighting with power, Akima's polynomial with extrapolation, Akima's polynomial with a boundary at the minimum z value. That means there's no extrapolation. And the Biharmonic spline. X and Y values may also be standardized, which keeps both variables using the same units. An XY scatter plot may be produced to view the coverage region beyond which extrapolation is required. So looking at the scatter plot is useful to get an idea where you can be confident and where you're actually extrapolating. Now, which method should be used? Well, depends on the data. Inverse distance weighting is more robust to outliers and sudden transitions than Akima or Biharmonic, but it will not be as accurate for a smooth response. So what we have here is we do leave one out cross-validation, and then we compute cross-validation R-square and root mean square error. And there is a limit. Limit is 100. Just to keep the computation, there's a lot of calculations that are going on here because it's effectively having to redo the whole analysis with excluding one data point. And then based on that, you can then decide which methodology is the best methodology to produce your contour surface plot. So if you just use the default, it will go through inverse distance weighting with power values from 1 to 12. It will use Akima's polynomial with extrapolation. It will use Biharmonic spline. For each of these, it will use a with and without XY standardization. And then the method that produces the lowest RMSE, lowest root mean square error, is the method that is used. All right, so it's pretty sophisticated. And with that, without further ado, let's demo that. So again, we're going to use customer data. So Graphical Tools and XYZ contour surface. So the response, we're going to do overall satisfaction by responsive to calls and ease of communications. I am going to use the automatic with cross-validation. If you were to specify a method, you can experiment and try different things and then look at the root mean square error. But you may as well just go automatic and let the software do the hard stuff. Definitely we want to look at the XY scatter plot. If you specify automatic, this is grayed out. Okay, it is going to use cross-validation up to a maximum of 100 data points. All right, so we'll click OK. And this is our contour plot, and this is our surface plot. Very nice visual display. You can see that if you want to increase overall satisfaction, you have to increase ease of communications, and you have to increase responsive to calls. Now, by the way, if I right-click, I can do 3D rotation with this. So I can rotate on the x-axis. I can rotate on the y-axis, so I can kind of look at this in different ways. So that's the XYZ surface plot. Now, here are the summary statistics. It tells you the method that was used. So based on leave one out cross-validation, it selected the inverse distance weighting with a power of 3. It did not standardize the XY. It's using the mesh 20 by 20. And here's the RMSE, R-square of 84% in RMSE of 0.29. Now, the XY scatter plot shows you that you've got lots of data here, so you know your interpolation is going to be pretty good with high ease of communication and high responsive to calls. But if you have high ease of communication and low responsive to calls, you're in extrapolation region. So you got to be careful. Similar here, if you have low ease of communication and high responsive to calls, you don't have data, so you're extrapolating. All right, so the XY scatter plot is kind of a nice complement to the contour plot to kind of help you to see what you can be confident in and what you have to be careful with. All right, so that's the that is the XY contour plot. And that does conclude our presentation, our part 1 of 3. And I would like to open it up to any questions. All right, so I have a question here. I'll just read the question out. I was wondering if SigmaXL can be used with Power BI's robotic process automation and visual designer desktop, since SigmaXL sits on top of Microsoft Excel. And the answer is no, we are a pure Excel add-in, so we don't have any hooks into Power BI. So that's kind of a separate tool. What we're doing is we're providing additional statistical and graphical tools to Excel. As long as the data is in Excel, in an Excel worksheet, then you can use SigmaXL to do your analysis. Another question, will SigmaXL updates be pushed automatically or can be downloaded manually? We don't have an automatic update, so you will have to download manually. If you don't have version 10, you will need to download it and do the install. Question, is there a SigmaXL workbook? Thank you for asking. You can get to the workbook by going Help, SigmaXL Guide, and that brings up your PDF. And I think right now we're up to, we're well over 1,000 pages. So you do have a table of contents. So you can basically go through, and this is a detailed, basically gives you everything that you wanted to know, all the examples. Also, there is the appendices. So if you wanted to, let's say you wanted to get more information on, let's see. If you wanted more information on XYZ contour plot, you could go here. And this gives you the formulas that I mentioned for inverse distance weighting, Biharmonic spline, Akima's polynomial, and so on. All right. So, okay, so it looks like we've got all the questions. So I want to thank everybody for your participation. Thanks, John, for your compliment. I appreciate that. And like I said, we can discuss the coloring of the p-value aside. But thank you for your participation. Thank you all for attending, and I hope you found this useful. Let me go back to my PowerPoint, which shows the upcoming webinars. So on Thursday, August the 31st, we have the general linear model. That's a very nice addition that allows sources of variation studies, a mixed effects model, that sort of thing. You can do more advanced measurement systems analysis using the GLM tool. And then on September the 28th, we'll cover the additional statistical tools that we haven't not covered, and then the MSA templates, including Deming regression. In a couple of weeks, this webinar will be available for download, and the PowerPoint and the data, the mobile data, will be available soon. Okay, so I think we'll call that a wrap, and thank you all very much, and we'll see you all on August 31st. Thank you.